Our group did stoichiometry. Molar mass is the weight in grams of an entire mole of particles of a specific substance. The molar mass for individual elements can be found at the bottom of the elements box on the periodic table, such as beryllium right there. There's a useful picture that lays out how to convert between different units, such as moles, liters, grams, and particles. When using this image, remember to divide out and multiply inwards. A BCA table is used to find the units of a reaction when only one side's measurements are known. The first line is used to show which reaction you're working with. The second line is B, which stands for before. It's used to show the initial amounts of the reactants. The third line, C, standing for change, shows the additions or subtractions of the moles. The fourth line, A, standing for after, shows the amounts after the reaction has taken place. For this one equation is the decomposition of water, the equation of which is 2H2O, turning into 2H2 and O2. The question says that there's 2.3 moles, which means there's going to be 2.3 moles of H2. And then, because the reaction has not taken place yet, there's 0 H2 and 0 O2. When the reaction happens, there will be 2.3 moles of H2 used. So you put a negative 2.3 in the change column, or change row. And then, because there's the same amount of H2 as there is H2O, because there's a 2 and a 2 there, you do 2.3 for the H2. But for the O2, there's only 1, so which means that you have to do a ratio of 1/2. So you do plus 1.2. Then you do all the addition and subtraction. So there's 0 H2O left, and there's now 2.3 moles of H2 and 1.2 moles of O2. That is how you do a BCA table.
To get the molecular formula from the empirical formula, first calculate the empirical molar mass. Then take the molar mass of the compound and divide it by the empirical molar mass. Multiply all your subscripts of the empirical formula by the above answer. Let's try an example. A compound has the empirical formula NO2 and a molar mass of 92 grams per mole. What is the molecular formula? First, let's find the molar masses. Nitrogen has a molar mass of 14.01 grams per mole. Oxygen has a molar mass of 16 grams per mole. When you add these together, you get 46.01 grams per mole. So, we divide the molar mass 92 grams by the empirical molar mass 46.01 and get 2. If you multiply all the subscripts by 2, the molecular formula is N2O4. To determine percent composition by mass of a given compound, first find the element you're looking for. Then divide the element's mass by the mass of the entire compound. Multiply by 100 to get the percent composition. This is an equation for this. Let's try an example. What is the percent composition of carbon in CH4? First, let's find the molar masses. The molar mass of hydrogen is 1.01 grams per mole. The molar mass of carbon is 12.01 grams per mole. Add all the masses together to get the mass of the compound. 12.01 plus 1.01 times 4 equals 16.05. Divide the mass of the element carbon, 12.01, by the total mass of the compound. Don't forget about sig figs. You get 0.7483. Now let's multiply by 100 to get the percent, 74.83%. So the percent composition of carbon and carbon tetrahydride is 74.83%.
A molecular formula tells us exactly how many of each atom are in a molecule. For example, C6H12O6. An empirical formula tells us the simplest ratio of atoms in a molecule. For example, CH2O instead of C6H12O6. We find a substance's empirical formula by dividing all subscripts of the molecular formula by the greatest common divisor. In C6H4O2, the greatest common divisor is 2, so we divide all the subscripts by 2. Our empirical formula is C3H2O. Here's another problem. A compound has 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. What is the empirical formula for this compound? First, we convert grams to moles and circle the smallest number of moles. Then we divide each mole by the smallest number of moles and write these numbers as subscripts. Lastly, we multiply each subscript by the smallest whole number that will convert all subscripts to whole numbers. However, we don't need to do that in this case. Our empirical formula for this compound is CaO2H2. If we were given percents of a compound to begin with instead of grams, we would assume we have 100 grams of the compound and change the percents to grams. For example, if a compound is 25% oxygen, we assume we have 25 grams of oxygen. Thanks for listening.